So let's take a trip down memory lane. Unfortunately, the bad memories are there too. So what happened in 1995 was kind of an explosion of dangerous new function into the browser space. This was due to all of us at Netscape. We were feeling competitive heat from Microsoft, even though IE was nowhere then. IE2 wasn't even out, I don't think. But we knew because Microsoft had tried to buy Netscape for not enough money in late '94 that they were coming after us. They were told to go get lost when they made a lowball offer by Jim Clark and Jim Barksdale, and they went away mad. They still took a little while getting their act together. They had this whole AOL killer called Blackbird going in '94. But when they saw Netscape 1 come out and take over from Mosaic, they realized something was happening that was important. Bill Gates at some point wrote his famous internet tidal wave memo. And Gates was really good at cracking the whip and getting everybody to line up in March. And they did that. And we knew they were doing that throughout '95 and '96. And that led to IE4 in '97, '98, which was actually pretty good for the time. But because we knew Microsoft was coming, and because Andreessen and I and others wanted to make the web into a programmable platform on the client side, and we'd already done things like plugins in Netscape 1.1, we set ourselves up to do a platform push in Netscape 2. And I should say plugins were really meant to be short-lived, haha. They were just temporary until the web evolved to have audio and video and multimedia intrinsics in HTML. This hasn't happened even yet, though it's in HTML5 and it's coming. It's almost there. You can do audio and video. You can use WebGL. You can request animation frame. You can do a lot of things that Flash was required for a long time. But plugins were meant to be temporary, and they weren't programmable from script. They just were an embedded rectangle that did their own media player or whatever, their own game. Frames and frame sets came in Netscape 2, and they were just elaborations of the multi-window model that was in all apps at the time to allow tiled and nested rectangular windows, sort of competing with AOL's user interface. And those were being hacked together for Netscape 2. When I joined Netscape in April, I got diverted into the server team due to a hiring requisition problem. And I actually wasted a month on something that actually now looks a lot like Speedy. It was not going to happen. It was supposed to be HTTP 1.1. It was intended to allow you to multiplex and have multiple streams without having multiple connections. Finally, I got into the client group in May, and I did JavaScript in 10 days. And I've talked about this many times. You've probably heard it. It's kind of boring. It's kind of stupid, too, except that that's how things happen in evolving systems under pressure. Like it's competitive pressure here. It could be like habitat pressure, some kind of big climate shift. This was that time. This was when things were really speeding up and in a dangerous way, but a way that you can't really take back. And I wish I had a time machine. I don't. But I did JavaScript in 10 days, and it wasn't just the core language, which had some mistakes, but had some big wins that helped it to endure and actually thrive and through some fixes and some evolution do well. It was the so-called document object model. We didn't even call it that then. It was just the browser integration. It was things like opening a window, navigating a window, playing around with cookies so that you could script them, you could grab them, forcing forms to submit or forcing links to be navigated. And something I added, because the Netscape browser engine was so primitive and not ready for a scripting engine to be wedged into it, the JavaScript colon URL, about the only thing the engine was designed to do was to load URLs. It was not designed to have you update a document after it had been laid out. And so the early DOM didn't allow you to do sort of constructive synthesis of nodes and elements. You had to generate a document using JavaScript colon URL or using something called document.write, which is still the fastest way to generate an inserted add. according to the Velocity Conference presentation by a couple of Google guys. And this is ironic. The DOM evolved in following years to have all sorts of Java-like APIs for creating elements and inserting them and getting ranges and doing editing. Those are all slower than document write, still. In the course of doing this, I had the thought, what about security? Because if you have multiple windows opened, and remember there's a URL first parameter of the window that opened, can someone actually attack someone else's site? Could a bad site load your bank into a window and lure you into interacting with it and then steal away your credentials? Could some merchant online steal away your, be tricked into giving up your credit card? This is still a problem, as you all know, but I didn't have much time to think about it, so I thought, what should I use to identify the principals, the actors in this security model, so that I can isolate them? And I came up with this idea of the origin, which is part of the URL. The standard URL is scheme://host, maybe an optional port. I included the port because I knew there were obvious differences between HTTP and HTTPS, and people were running experimental servers on non-standard ports, so I thought those should not be same origin. I tried labeling everything with origin, but I didn't want to actually copy it around, so there's a sort of a unforgeable link up the containment hierarchy in the data model, the DOM, that gets you to the window, which is the container for the document, and that's where the data origin label lives. And code, when it's compiled, has the origin of the document it was loaded from. The script tag was embedded in, copied into the compiled code. So you can make these sort of access control judgments based on the subject and the object, the running code and the data that it's looking at. And it's done based on this origin substring of the URL, and it's based on a string compare. There were lots of bugs. You may familiarize yourself with these at OWASP or Wikipedia. Even now there are bugs, but then there were horrendous bugs. The file clone URLs were all same origin. This was a big problem. They're now, each file has its own origin. This is a little restrictive when you want to have a sort of a sub-tree in your file system, have same origin relations. And we're working on how to fix that in the standards process. I don't think that's been solved yet. Some of the funny URLs Netscape came up with over the years for mail also need to have finer grained origin than just the scheme, host, and port. They need to have each message be its own origin. So these were patched. So right away we're in this mode of taking a simple idea that's too simple, simplistic, and patching it, and that's a bad smell. But we're also in an evolving system with competitive dynamic where you don't get to take back mistakes. You have to sort of evolve along a path and try to correct course and not get boxed into a canyon where you go extinct. So that evolution continued in Netscape 3, and at this point, IE3 was coming along, and you could tell that Microsoft was serious about the web. When Microsoft gets serious, they start iterating, and by the time they get to version 3, things are looking threatening, and by the time they get to version 4, they're actually better than whatever they embraced and extended. So there wasn't much we could do here. Netscape was also killing itself by using its IPO mad money to acquire a bunch of startups that had nothing to do with browsers or security. They acquired a bunch of server companies, again, not much help on security. They acquired a bunch of enterprise groupware sort of related companies, well, one in particular, and that helped take Netscape down. So it wasn't just Microsoft. And some of us, like I was the only guy on JavaScript this whole time, were having this doomed feeling. It became a mantra around Netscape. But we persevered for some crazy reason, and eventually, around the time of Netscape 4, I did get help. There was a JavaScript team finally. There was also a giant Java team heading for a layoff. Java was something that everybody thought would be the big, serious language everyone who was a real programmer used, and JavaScript was just this silly, duct tape language, a term I do not like, that you would use to glue together these Java components. Unfortunately, the components were at first applets, and really those are just like plugins, and Java never really got integrated deeper into the browser. It never had the ability to inspect the DOM except through JavaScript. Sun was just going in a different direction. Netscape was abandoning its platform intentions, trying to get into other businesses as Windows bundled IE and took away all the profit from the browser market. So even in spite of that, persevering meant finishing some of the things we wanted to do in Netscape 2, I added support for script loading, script source equals. And I allowed it to go cross-site because, hey, everything does. Images do. There's lots of ways to do this in HTML. Even then, in HTML3 too, you could go cross-site. So why not? And it was intended to be like pound include. You could just have your resources on a scripts.yahoo.com and you could load them from finance.yahoo.com or whatever. And there shouldn't be any, in principle, any reason why the origin definition should prevent you from doing that. You're just sort of pound including them. You're bringing them into your own trusted computing base. Not a good idea. Unfortunately, that's one of those decisions that we can't really recall easily, though I'll talk about trying to do that at the end. And I added something called document.domain because, again, people were writing things like shared assets.yahoo.com and games.yahoo.com, and they wanted scripts in those two to be same origin. So only by mutualism, by both of those sites' scripts saying document.domain equals yahoo.com, they join their superdomain. This seemed like a good idea too. It's something that has not grown well. It changed the effective origin of the mutual scripts, but it did not change in the long run all the notions of origin. As the web has evolved and as Ian Hickson has worked on HTML5, we've stepped away from this notion that document.domain can change your origin. It now changes your effective origin, and only certain judgments are based on the same origin test applied to the effective origin. Others still are new tests apply to the original origin. There's a history of people using document.domain improperly. There's also been some problems with browser implementations where it wasn't really secure. You didn't have to have both parties do it. And of course, we're trusting the DNS, which is another point of attack. I was going to list a bunch of XSS history here, but it's actually too depressing. And I've been traveling, and I started to do it, and I just couldn't do it. I had to lie down until I felt better. You can find this pretty well documented, and it's been ably studied by fine academic researchers. Adam Barth and Colin Jackson, when they were at Stanford, did a lot of great work here, taxonomizing it. Basically it's code injection or code and text encoding problems that allow confusion of code and data. Data for code. Something that looks benign becomes injected script. And then, XSS can provide grounds for CSRF. I'm not going to talk about CSRF too much. I think OWASP best practices has that one licked. I hope so anyway. But, there are things we can do. There are browser-based attempts to do filters for reflected XSSs. We saw problems there, right? IE8 tried it, and it led to actual new exploits. It's tricky to do. I think the way Chrome does it is good. It still has a few false positives. And that leads me to the topic I really want to present to you, because I think this is possibly that box canyon that may lead to extinction, but we may find a path out of it and live. And that is that in the browser game theory, I think Jeremiah must have talked about this earlier today, the battle of browsers, none of them will actually break the web to improve it, to fix some of these design flaws. Because if they do, they lose market share. And even if they don't lose market share, they're taking a bet. Say they don't break it, they just add something better that's new and that's on the side. And over time, you can evangelize that, and developers should migrate to that, and OWASP can help server-side people see that that's a better practice and switch to that. The battle thing is still there as an attractive nuisance, but with enough deprecation and time and enough better developer ergonomics and evangelization of the new thing, eventually people switch to the new thing, and then you kill the old thing. I believe in this approach. This can be done, but it has to be done fairly incrementally. If you try to do a big jump to something new, then beyond the obvious risk that you're going to make mistakes there too, because the more complex, the more likely it is to have problems that you don't want to commit to, and therefore you can't evangelize people to yet. Let's assume you get it right. But if it's a big enough jump, it takes a lot of time to do, so it has direct and opportunity costs. It adds risk. It means you're taking your eye off the ball competing on the old web standards. That's the game theory we're all in. I don't think it's the bad browsers. I think it's just the laws of the jungle, right? It's the way things have to be if you're in a market where switching browsers is fairly lightweight. Browsers import each other's profiles. Users are told, hey, there's a new browser. Browsers have some stickiness based on loyalty and brand values that are kind of ephemeral, or they're meaningful to users, and they summarize a whole bunch of judgments about trustworthiness and fitness, performance, but people can switch, and they do switch. Since Firefox took that market share from IE, we showed that this was possible. Mozilla succeeded. We have the world we want. We have a competitive browser market. It's more balanced than it's ever been. This is good for the standards to evolve quickly, as long as it's incremental enough, but it's bad if you try big jumps. So Google Chrome, very fast, came in as the fast to start, lightweight browser, minimal user interface, mostly the document. I remember seeing Chrome when it launched in 2008. Somebody was running it on Windows, and I was like, "Is that Notepad? No, wait, that's Chrome." It's grown since then. And I use Chrome every day. I use Firefox every day. I co-browse, and Chrome has its limits too. It doesn't use process isolation above a certain number of tabs or windows for non-HTTPS. I noticed this. It has the best Flash integration, which money can buy, but it still has problems where Flash CPU hogs or hangs. And it seems to scale less well for me than the latest Firefox in terms of tabs and windows. I have twice as many in Firefox. Firefox has jank bugs because it doesn't have as much process isolation, it has too much synchronous I/O, but it does tend to compete. And the latest browser market share numbers from network applications bear this out. Firefox is back in number 2. I don't know what the truth is. It's like Chrome and Firefox are like this, but it's great because nobody has a lock on the market. Nobody owns the web, and that's important because I think there's a lot of value in spite of the horrible security problems on the web with all the assets in the web. The fact that the end-to-end principle and the endurance of the web standards means we can create these long-lived artifacts and share them. We can hyperlink them. That is still the web's biggest virtue, the reach, the depth of linking, the fact that you don't need permission to publish, anybody can do it. But those are important points. Those are obviously near and dear to Mozilla's mission. So I don't think vendors are too conservative. I think they're trapped in this system, and the best thing we can do is find incremental evolutionary steps that don't add too much risk, don't have too much cost against the incumbent standards, and that we can all make the hop together. And with a more competitive browser market, I think we can. So I would encourage everybody here who's interested in this to contribute to the open source browsers and to the standards process, which is also more open than it's ever been. Right? W3C lets people join the HTML list. It's kind of noisy. You have to live with that. But if you have a good idea and you can prototype it and promote it, and it's small enough, but it makes things better, you can get it in. And that's valuable. So again, that slide was from Colin Jackson's Usenix Security 2011 talk. It was a very good talk. It made the point about browser game theory in more detail. And it was trying to get security researchers also to not invent sky castles or academic, perfect security worlds which don't exist and can never be implemented, and actually try to work with the browser vendors, get smaller experiments done, get smaller ideas tested and implemented and possibly standardized and adopted. To say there's opportunity costs. Here's an example. We wanted to have an alternate language to JavaScript for our user interface, which we've called Chrome forever, ironically. I don't think there's anything to do with the Google guys choosing Chrome as the browser name. And so we commissioned Mark Hammond of Windows Python fame to integrate CPython. It's a lot of work. Ended up only being used by Active State. There's no distribution channel for CPython itself. CPython has, it's got a lot of advantages. It's long-lived, it's stable, it's clean code, developed more to be maintainable and pedagogical than to be super fast. There's a lot of good things about it, except that it also has like unsafe FFIs and OS-dependent thread and other APIs. And there's no distribution on Windows, and I don't think Mac has it unless people install it with darn ports or something like that. So the costs here were high enough and the payoff was low that we ended up ripping it out. And that makes me sad. Another thing I should mention here is if you try to integrate a second language, you have, besides the attack surface I hinted at with mentioning the foreign function interface that's unsafe and the threading APIs, Python wasn't developed in a paranoid sandbox browser environment. Not that I was paranoid enough, but at least I was trying to do same origin. I was trying to do least authority where I could. Python is for like Unix hackers to write programs in, scripts in. It's like Perl and other languages. That is a more trusted mode of operation. So you'd have to do some re-engineering, and then you'd get sort of a subset of Python or a different Python. The other thing that really is worth pointing out, because I still get people asking, but why couldn't you do language X in 1995, is language X, let's say it was Lua or like Python 1.2, I think, pretty old, would have been a fly in amber. It would have been frozen instantly. It would have been probably cloned by Microsoft unless they managed to kill it with VBScript, which is the other threat that JavaScript prevented. And then it would have been subject to this slow ECMA standardization process. Not necessarily intrinsically slow, but slow as IA took over the market. So, doing new things like languages, and Google's trying this with Dart, it's very costly and it's unlikely to lead to standardization, or at least a standard that everybody can agree on. JavaScript wasn't particularly great, but it was early enough that it got in there. It was sort of like, those early mammals. The dinosaurs must have been thinking, what are these furry things jumping around me for? But then the oxygen level of the atmosphere went down and things got colder and we don't know what else happened. Dinosaurs weren't laughing. The mammals had the last laugh. And JavaScript is more like that. It's something that seems kind of stupid at first, but it had the right energetics to endure, and it's really hard to displace. And I'm not bragging here. This is something I would hope to see go away. My current best thought is that the way JavaScript goes away is it becomes a VM language, and we're actually working on this in Mozilla Research. But to get back to security, I think there are some things in JavaScript that help. And I'm sure Doug talked about them. I missed his talk because of my travels. One is that JavaScript almost has an object capability model. And there's a paper by Don Song, Joel Weinberger, and Adam Barth about this, where they actually noticed that the JavaScript layer, except for a few big loopholes, doesn't let you reach through the object graph across origins. And the window object is one of those big loopholes. And that's sometimes used as a mediation point unsafely. Meanwhile, the DOM has this sort of, can I look at the other window's properties, or can I look at some random object access control model? And access control models have notorious problems. So in this paper, Barth, Weinberger, and Song, they show how they worked on WebKit. They made an extra layer of checking in the JavaScript engine that verifies, it flexes those object capability links, those points of connection, those capabilities that have been granted, by testing the DOM access control relation across them. And sure enough, they found bugs. These are not bugs unique to WebKit at the time. This was like 4 years ago. Mozilla's had similar bugs. Like, as you navigate, the navigator object is conserved in the same origin navigation flow. It's a point of capability leak. And by doing this extra access control check on top of the following of the reference, following the capability, sure enough, they found a bug. I think they found a couple. And these are, like I said, bugs that other browsers have had. But it shows that the OCAP model is actually almost there in JavaScript, and it's stronger. And so we're building that up in ECMA standards body. We have ECMAScript 5 in all the major browsers. We have ECMAScript 6 underway, and it is being prototyped in Chrome under a flag still, but I think that'll be lifted soon, and in Firefox, where it's on. ES5 has useStrict. We have a bunch of new facilities for hardening objects, freezing them, increasing the integrity, decreasing the mutability. That's helped Caja or secure ECMAScript. And for things outside JavaScript, because security is cross-cutting, you have to look at the whole system. I think OWASP has done a lot of good. There's just been an evolution of best practices knowledge. Standards have evolved. The origin header, it's ignoring plugins. We've had some progress. And one of the biggest things that I like is the use of OCAP to do things in JavaScript or in the VM in a way that doesn't require this lossy DOM access control check, the same origin check. So if you think about a JavaScript VM, there are objects in the JavaScript language you can address, and backing them there are often what are called host objects or DOM objects. These have a sort of a vtable behind them, a C++ object. Great source of woe. You can do all sorts of things, especially if you have writable executable memory. Even if you don't, you can do RLP, lots of bad stuff. But you can also use JavaScript to isolate things better with this sort of meta layer. You can write JavaScript membranes, and I'll show this in a minute. You can even write them in the language. That's coming in ES6. You can do some of it in ES5 if you know the names of all the properties, and it's prototyped in Firefox and V8. So we use these membranes, so-called, and they're extremely useful for things like Google Caja. the capability model says you have to introduce or bestow a reference to be able to do anything, and you can pass that reference transparently through a membrane in order to make it revocable, and in order to sort of consolidate your mediation, your pervasive mediation, to be implemented in as few lines of C++ as possible, or JavaScript as possible, so you can have a smaller trusted control base. And that's what we do in Firefox. And I think all the browsers do variations on this now. It's absolutely necessary. This little animation is going to show revocation in a minute. So right now we have the green layer and the gray layer, and then eventually we want to cut things off using the membranes to revoke access. And that's used. Here's a diagram of Firefox. The Chrome there doesn't mean the Google browser. It means Firefox user interface, which is where GreaseMonkey, for instance, might operate. These are isolated heaps. They're actually separate compartments. They could be process isolated in the future or thread isolated. So cool. It's more like an OCAP model. And now you do have cross compartment references. You have to if you have window.open. You can open another origin, page from another origin. You have a reference into that window, but it goes through a wrapper. That's the yellow thing. You'll notice the only arrows between the two compartments are from, the arrows are originating from the yellow circles. Those are the membranes or the wrappers. In this case, cross-origin wrappers. And not only can we revoke, again, we can consolidate our implementation of access control policies like the same origin policy. Now, here's something that I've been trying to get people interested in. I'm going to have to prototype it in Firefox to sell it, I think. I'm going to have to practice what I preach. It's a small enough change. It might break the web. Could be good. We have content security policy. Obviously, sites opt into that. They're going to break things on purpose because they don't want to use a val. They want to take away attack surface. But what if we could make cross-site scripts, instead of being pound included into your trusted computing base, make them be subsumed into the origin trust label lattice at a lower level from your page? They would be the origin of URL1 / URL2. And that would mean that you can make judgments on them that would distinguish them from your origin. You could say, hey, that's an ad I've included cross-site. I don't trust that thing to access my cookies, my form elements. I'll let it create new elements and fly them over annoyingly from the left in a CSS animation, but I will not let them see the rest of my DOM. That's what I propose with prototype, and I'm going to have to do it in Firefox, I think, at this point. So that's my pitch, and I'm happy to take questions if there's time. Thanks.
What do you think of HTML5 iframe sandboxing for use of advertising isolation?
I think it's good, and it's taking a while to get the spec and the implementations there, and then it'll take even longer to get these advertisers. Doug can tell you these advertisers are like somewhere in Russia, and they're like 7 degrees of business separation from you, the content site, the relying party, and it's going to take a long time. I don't know if you notice on YouTube, there's a lot of WebM, VPA. Google did that because they wanted an unencumbered video format, but they still use Flash and H.264 because the ads on YouTube require Flash to do ad insertion, and those advertisers are also very slow to change. So it'll be another good tool in the belt when it's there. It's not clear there'll be one true way to do advertisements. I mean, iframes have certain limitations in the CSS layout model. And these annoying things that fly in over top of your text, I'm not sure those can be done with sandboxed iframes. Maybe somebody knows. People want to inject a div directly, right? You guys know? I don't know. I would project the same origin policy into the capability model and use the capability model as the primitive layer. Capabilities, some people become such ardent fans of them that they seem like they're members of a cult, but I actually think that's the solid way to build high integrity systems. If you don't have a reference to something, you can't mess with it. So membranes, revocation, limited authority, that's good stuff. That's what I would have done if I had time and had my head on straight in 1995.
All right, thanks.
Thanks.